Welcome back to Notebook. We are here today with another new lesson in maths. Kids, you must know how a straight line looks, right? This is a straight line. Suppose using a ruler and a pencil, you draw two straight lines so that they touch one another and also can be clearly seen separately. If they do not touch but can be seen, the lines will look like this. And if they touch each other but cannot be seen, then they will look like this. The trick is, from a point on one of the lines, draw another one like this. It should look like a horizontal V. Color the space between the lines. If you erase the previous top line and draw another one a little away from the one below, you see that you have to color some more in the space between the lines. If you remove the top line yet again and draw another one further away, there is again some more space to be colored, right? You can continue erasing and drawing the top line, pushing it further and further away from the baseline, and every time the space between them is more and more. Do you know what this space is called? It is called an angle. The nearer the two lines, the smaller is the angle. The farther the two lines, the bigger is the angle. Imagine the two lines as two jaws of a crocodile. When he eats a fish, the jaws are nearer. For a bigger animal like a hen, he opens them further up. For an even bigger cow, he opens them totally. The angle between the jaws keeps getting bigger and bigger. These kinds of angles are seen in most animals' mouths, but they are prominently seen in beaks of birds. You can see angles in many daily objects. For example, hands of a clock, hands of a scissor, and so on. Here, the way lines move to make angles, they look like a hand moving up or down on its elbow, isn't it? No wonder that the baseline of an angle is called a base, and the top line is the hand. In all these angles, the lines marked in green are the bases, and the lines marked in yellow are the hands. Suppose when you draw an angle from any point on the base, just to fix the point where the hand touches the base, you draw a small plant. On the top of the hand, you draw a sun. Fix a point on the base near the sun with a rock, such that when the hand moves to make various angles, the sun moves away from the rock. When the sun is right at the top of the plant, the angle looks like an L, isn't it? This kind of an angle is called a right angle. All these are examples of a right angle. Anything that stands straight upright forms a right angle with a horizontal line. Now, when the sun was near to the rock, the angle was small. It is smaller than the right angle. In fact, all the angles that the sun makes with the base until the sun reaches the top of the plant are less than right angles. Angles which are less than right angles are called acute angles. Now, when the sun moves further away from the rock, beyond the right angle, the angles get even bigger and bigger. These angles, bigger than the right angle, are called obtuse angles. So, the angles on the right of the right angle are acute angles, and angles on the left of the right angle are called obtuse angles. Children, do you remember that weights are measured in kgs and lengths in meters? The measure of angles also has a name. Angles are measured in degrees. For example, a right angle is 90 degrees. All acute angles are less than 90 degrees. For example, 30 degrees, 40 degrees, and so on. All obtuse angles are more than 90 degrees. For example, 100 degrees, 120 degrees, etc. At some point, the sun moves so much away from the rock that it hits the base on the other side, and the hand and the base cannot be differentiated. They look like the same line, isn't it? This full angle is called a straight angle, as the two lines look like one straight line. The measure of this angle is 180 degrees. There are some special acute angles. which will help us in solving problems in the future. 1/3 of a right angle is 90 divided by 3 is equal to 30 degrees. Half of a right angle is 90 divided by 2, which is 45 degrees. Twice of 1/3 of a right angle is 30 into 2 is equal to 60 degrees. You can see many examples around you which resemble these angles. For example, when you open a hand fan like this, it is 30 degrees. When it opens further, it is 45 degrees. Even more, it is 60 degrees. And finally, it is 90 degrees. If you open the fan more, you have 120 degrees, 135 degrees, and so on. When the fan is fully open, it is a straight angle that is 180 degrees. The fan now looks like a half circle or an inverted D. We use a similar looking instrument to measure and draw angles. It is called a protractor. You will find it in your geometry box. To measure an angle, you have to place the protractor on the point on the base where the angle is drawn. Then check on the edges. See which division on the scale looks like it is on top of the hand. That is your angle. For example, in this one, the hand is along the division for 58. So the angle is 58 degrees. These three look like 45 degrees, 30 degrees, and 160 degrees. Do try to remember how these special angles look like. Let's see some magic. You can draw any angle and measure it. Suppose it is 60 degrees. Now, if you rotate your copy and make the hand your base and base your hand, you will see that the new hand is coinciding with 120 degrees. How is that possible? How can the same angle have two different measures? You will learn that in your higher classes. Children, hope you had a lot of fun learning about angles. With that, we come to the end of this video lesson. We hope you found this helpful. Keep practicing your maths and keep watching notebook videos again and again so that you get really good at your topics. See you soon. Goodbye.